Okay, this video just to show you one more log graph problem and a couple of we assumption question at the end of it, which you need to know how to answer, but also just to show the order in which you may have to do things. So in this example, it says the volume and pressures of a gas is given in the table below. So we get the pressure P and the volume V, and it says if the relationship is P is equal to AV to the power of M, by drawing an appropriate graph, find A and M. Now, the first thing you need to know why you're putting in. It's pretty obvious you have to put log P and log V because there's no other variables given, but why it is going to be that. So first thing I would do this before I do this really is I would work out, do my log equation here so that I know what I'm going to be finding. So I'm going to just take logs. So we had log of P is equal to log of AV to the power of M. That's going to be log of P is equal to log of A plus M log of V. And I'll just rewrite that as log of P is equal to M log V plus log A. So here it is clear my gradient is equal to M and my intercept then is log A, but we'll not be able to find the intercept from our log graph. So we're just going to look at how we'd actually go about finding the gradient. So here, in this case, M is going to be equal to, oh, sorry, I forgot to say, and also that's my Y equals MX plus C. So log P goes on the vertical, log V goes on the horizontal. So just fill that in now. That's going to be my log P goes here, and my log V goes here. So I'm just going to pause the video, and all I'm going to do here is write all of these in. So do log of 29.47, log of 22.61, log of 18.1, and so on, and the same for all of these, and just fill these in, just so we're not wasting time watching me writing these all down. Okay, so I've just filled in. This is my log P, and this is my log V, and I've just filled those in. So once we've done that, I'm just going to go look it down and see how we actually find our value of our M first of all, which was our gradient. So log M is log P difference over your log V difference. So to do this, I picked these two values here. So I picked this one here, this pair of values I should say, and this pair of values. So I'm going to do the log P, so this one minus this one over this one minus this one. And you can see I've done that here. And I got minus 1.4 to 1 decimal place. Once you find an unknown, rewrite it. So I'm going to put it into the original equation, which was P is equal to AV to the power of now minus 1.4. And I'm going to pick one of my points. P was equal to 29.47 and V was equal to 120. So just fill that in. That's 29.47 is equal to A times 120 to the power of minus 1.4. So that means my A is going to be equal to 29.47 divided by 120 to the power of minus 1.4. So that works out to be my A to be 24001.3 to 1 decimal place. Now that's such a big number, I would definitely be going to 1 DPs because it is going to make a big difference. If you don't, so don't be going to one significant figures rounding up to whatever it would be 20,000. That would be too big an error, so 1 DP instead of significant figures. So that tells me therefore my P is equal to, I've now got my A, so 24001.3, and then that's going to be times V to the power of minus 1.4. Okay, what I have forgot to do here, it says by drawing an appropriate graph. So I've done all of this without drawing the graph. So just to show you can do this without the graph. But to get the marks in the exam, you do need to have your graph. So I'm going to go down and look at doing my graph now. Okay, just have a look and see I've got my log P labeled on my vertical axis, my log V on the horizontal axis. And again, notice just as in the last example, I didn't start at the origin. I started at, well, it would have been 2.0 on my horizontal and 1.1 on my vertical. And I've missed a point here. I've got another wee point to mark on here. That's me. So there's my 5 points marked on. Now you can see they're in a straight line. link those up with a straight line as well. I will do that in a wee minute so I can do it well. But you can see it's a good, decent sized graph. So I picked an appropriate scale such that they're nicely spaced out. Now, you don't have to draw on your rectangles or anything. Remember how we got our gradient. We used this first point here and this last point to get the gradient. And remember, we couldn't have just traced back to get the y-intercept, the vertical intercept, I should say, because this doesn't go through the origin. So this isn't the origin here. So that's what you would do. So I'm just going to pause. I'm going to draw on the straight line, and then we'll do the rest of the question. Okay, you can see I've just drawn on a straight line. So now we're going to go back up and answer the rest of this question. So it says, use your equation to find a pressure with a volume of 200 centimeters squared. Now it says use your equation, so that means you have to use your equation. It doesn't say use the graph. So if it did say use the graph, you would have to do it by going across and down or up and across or whatever. But we have to use the equation for this bit. So we're going to go up here and we're going to answer part 1. So part 1, first thing you want to do is just write down the equation again. It wasn't V, it was P was equal to 2400 1.3 times V to the minus 1.4. So in this question it said find the pressure with a volume of 200. So just say when V equals 200, P is equal to 2400 1.3 upon 200, and that 200 is the power of minus 1.4. Hit that into your calculator, and I got 14.4, and the units were pascals, and that's to 1 decimal place. Okay, part 2 says find the volume when a pressure of 10 pascals. When a pressure is 10 pascals, stating any assumptions you make. Right, let's look at the graph first, and we'll sort the assumptions bit out first, or talk about it first. If you look at your graph, you can see we do not go as far up as 10 pascals. So we're really assuming that as we go up higher, that the same relationship is maintained. Now, if you think of certain things, like in physics, you have Hooke's law, where it might be a straight line. The extension of a string is directly proportional to the force applied, but that happens up to a certain point, and then that relationship does not exist anymore. So here we are having to assume, based on the data we have, we really can only accurately tell what the volume would be within a certain range, and it's this range here. Likewise, what the path pressure would be within a certain range. So outside these ranges, so out this way or out this way, we don't really know what's happening. We can't be 100% sure. So the assumption we're making is that the relationship is held. So that's what they're talking about, but let's just answer the question first. So again, let's write down our formula. P was equal to 2400 1.3 times V to the minus 1.4, and just say when P is equal to 10, 10 is going to be equal to 2400 1.3 times V to the minus 1.4. That means 10 divided by the 2400 1.3 is equal to V to the minus 1.4. And if we just do that out, then I'm just going to write that as 10 over 2400 1.3 is equal to V to the minus 1.4. And then it's an awkward enough we question this, so what you can just do is just take logs. So I'm just going to say take logs. So log of the 10 over 2400 1.3 is equal to minus 1.4 times log of V, and then just dividing across, you're going to have log of that thing in the bracket, 10 over 2400 1.3 divided by minus 1.4 is equal to log of V, which gives me log of V is equal to 2.414453 ... So do your inverse log, which is, if you look at your log button, the inverse log is going to be 10 to the power of 2.414453. So that really is shift and log. So just like the inverse of sine is sine to the minus 1, or shift and sine, the inverse of cos is cos to the minus 1, or shift and cos. So on your calculator you just get that, and when I did that I got 259.7 volume, so centimeters cubed, to 1 dp. And the last wee bit will just say this is assuming the relationship, I'm going to run out of space here, the relationship holds beyond values given. Holds beyond values given. And that's it. Okay, that is a last exercise for your logs, and last bit of notes for your logs. And the exercise you're going to do is shown there. It is exercise 14b, and again that's from your CCA GCSE Further Mathematics book.